Good afternoon, everyone. I'm Sharon Dooley. I'm the moderator for today's session. I think we have a topic you're going to find very interesting. It's about the SQL Server 2017 new features. And you don't have to worry, there's not going to be any Linux in this presentation. Our speaker is Dave Williams. And I'd like to thank our sponsor, Quest. Their sponsorship is what allows us to give away goodies, gift cards after every session. Past Summit is coming November 6th through 9th in Seattle. We have a discount code. If you use this code VGSTRKGOE, you will get streaming access to all of the Summit 2017 content, and you'll be able to look at the types of presentations that were delivered. Starting on March 23rd, the first time the price for the Summit goes up, we will have another code, and that will give you a $150 discount. Now, for everybody who's the first-time visitor who uses our code, either one of them, we'll get a Visa gift card for $25, which we will offer to our attendees. And for every 20 uses of either of our codes, we'll get a complimentary registration to the summit in November. And that will also be raffled off to attendees. Summit call for speakers is open, and they'll be accepting abstract submissions until March 21st. If you think you're ready for speaking at the summit, go for it. If you think you're speaking but you're not quite ready for the summit and you have a DBA related topic, let me know and we'll find you a spot so you get some practice in. There's a Facebook Live on March 27th at 6 o'clock at 1800 UTC. Somebody will have to translate that for me because I don't know what it is. And Kendra Little's going to talk about data indexing. She's a very good speaker. This is a free event. Feel free to go. There'll be more information if you go to pass.org and look at the events. We are one of many virtual groups. Some of them focus on a particular area, like ours that focuses on database administration. There are also some that are language specific. So if you're a Russian speaker and would like to hear the presentations in Russian, that's the virtual group for you. And Women in Technology, they send out a newsletter keeping track of all the women that are speaking everywhere. If you want to participate in any of these, just go to your past profile and sign up, and you'll start getting mail telling you what the various groups are doing. If you've never been to a SQL Saturday, I recommend that you find one in your area. They're all over the world. It's a one-day event, a free conference, high-level presentations, and well worth attending. There may be a local chapter in your organization. Unlike this, which is all online, local chapters give you an opportunity for face-to-face networking and also offer opportunities to present. PASS is, aside from the staff, an all-volunteer organization, and there are plenty of opportunities to volunteer. And each month an outstanding volunteer is recognized for having shown extraordinary dedication and effort in service to the data professional community. Now, this is more aimed at the people who aren't here, because there's a bunch of folks who discover us on YouTube and sign up, but those folks only get to see the recordings because that's all I put on YouTube. And if you want supplemental materials like the PowerPoints or some of the demo scripts, you need to be a member of PASS. It's free and well worth doing. Now I'd like to introduce Dave. He's a cross-product DBA. With SQL Server, DB2, Oracle, Informix, and Sybase. He's got me beat by 2 of those. Who has worked for 25 years as a DBA for both private and local central government customers, including a Fortune 50 investment bank. He's certified as an MCSE and MCTS SQL Server 2008 DBA and developer, and he has certifications in other products as well. Dave has spoken at multiple SQL Saturdays, as well as local user groups, and is a regular volunteer at events, including SQL Bits. And you all came to hear Dave, not me, so I'm going to make him a presenter and turn the meeting over to him. Go for it, Dave.
Okay, can you okay, can you see my screen okay?
Yes.
Yeah, good. Okay, this is SQL Server 2017 new features. I'm not going to cover Linux support, as it's probably the headline feature for 2017 in terms of something that's so completely new. Each release ends up with each major release ends up with headline features. For 2014, it was the in-memory things. For 2016, for me, it was probably Query Store. For 2017, it's Linux, but I'm not covering that. I'm going to cover the other features. So yeah, I'm a speaker at SQL Saturdays and user groups. I'm also an IBM champion and very involved in all the different database communities. Really like the SQL Server community, especially as the fact that the actual engineering staff for SQL Server are very, very available. The actual main staff involved in terms of engineering and promoting SQL Server 2017 were Slava Oakes, who is the engineering manager for SQL Server 2017. Actually out on Twitter. You can contact him directly on Twitter. Also, there's their manager there, Tobias Turnstrom, who spoke at PASS Summit 2016, I believe it was, when I was there. And Travis Wright was also there at PASS Summit as well, 2016. They're all available in the community, quite easily contactable in the community. Travis puts out quite a lot of articles about 2017, and especially things like running in containers. And they actually have a Gitter chat area where you can actually chat with them specifically about DevOps, but it also covers everything about 2017 in general. So these people are the engineering people. They're very, very easy to get hold of. And they're always out there in the community promoting and telling you about the internals of the product as well, and features, and even come out with things that are actually going to be coming up in new features of the product, new releases of the product as well. So you even get a little bit of new features, and I'll be covering that as well about what's coming up as well. So it's amazing how open Microsoft are about their future plans and how easy it is to get hold of the engineering people. They're all directly contactable. This is the engineering manager, Slava Oakes. I think that might have been a shot from PASS Summit 2016, actually. So he's out there, he's talking about how they not only what they're doing to the product, but how they're managing the engineering side of the product as well, using Azure to actually do their testing. So very contactable. First thing I'll mention is Query Store, that my favorite feature out of 2016, where it can display query plans, and you can always manually force a good query plan in 2016. 2017 starts to add a bit more intelligence into the database in terms of feedback and learning. So it can automatically detect plan regressions. So you've got the Query Store turned on, assuming you have it turned on and it's writable. Then there's enough information in there now that it can start to look at the query plan, say, oh, the query plan for this particular query is changed, because they have the query text as well. And then say, well, if it's changed, maybe what we should do is force the last known good plan automatically. So I have automatic tuning for the database. So what happens is you turn on, for the database level, you turn on an automatic tuning option called force last good plan on. And then when the query regresses, the system will learn. It might take a bit of time, it might take a few executions, but it will actually start to produce an automatic tuning recommendation. And you've got DMVs for that. So like sys database automatic tuning options, you can see there's some kind of recommendation come along. It can be, you can either see that it's that the actual automatic tuning is turned on or turned off. So it can be disabled by the system. It can be because the query store's turned off, or the query store's read only. Or the one thing about this automatic tuning is this enterprise only feature. So it wouldn't be supported in other versions. So you're running your query, something changes, like maybe an index is dropped, or you've run up-to-date statistics, and the query plan has changed. What happens is the engine, after a few executions, and it's not quite defined how many, but maybe something like 20 or so, possibly less, you'll suddenly see in one of the new DMVs, DMDB tuning recommendations, as a recommendation will appear. And with 2016, you can start to have JSON in the database. They're actually using that now within DMVs to actually show you what's happened with these tuning recommendations. So what happens is it first appears as active, which means it's not yet being applied. It can be applied manually. So if you see it, you can actually go and force to that known good plan. When it does that, it will, first thing it will do when it starts to activate it is it will put it into a verifying state. So it goes off and it goes and says, okay, I'm going back to the last known good plan, but let's verify that actually improves my query performance. So it won't just apply it and blindly apply it. It will actually go off and do some verification, it'll go and force the plan to the last good plan, and then go and compare the performance compared to the bad plan, see if that actually worked and actually made a difference. So from verifying, it can actually go to success, which means, yes, it's been successfully applied. So it might be a bit confusing. Active does not mean the recommendation is active and being used. It has to actually go to a success state, and it says, okay, this new recommendation to go back to the previous good plan is actually successfully applied. Further down the line, it will do, even after that, it will carry on monitoring what's happening internally itself, SQL Server itself. And if it finds that actually there's no significant performance gains, it can even go and revert the recommendation and say, I'll go with what the optimizer currently thinks. I won't use the historic good plan. And even if you have actually gone to successfully applied the new plan, successfully applied the old good plan, what can happen after the time is, say that particular good plan depended upon an index existing. If you drop the index, obviously it can't use that plan anymore. So what happens is this tuning recommendation then becomes expired, means it cannot no longer be applied. So it is quite intelligent. It's always looking to see what happened. Does it help? Maybe I should revert it because it hasn't really helped, or I can expire it if it's no longer applicable. Just for reference, I'll put a load of items in there, give you a bit of recommendation as to why things might not happen, or last known good plans might not be applied. Things like cursors, bulk insert. These can actually stop things from happening. If you do a restart of the server while it's in the verifying state, you want to check the forcing the good plan was correct. You can abort the verify. Or if you do some kind of query store cleanup, it can abort the verify as well. And if it decides that during the verification process that using the last good plan doesn't help, then it can actually force a query recompile to pick up the current quote bad plan, as it were. So there's a lot of information in the DMVs to actually see what's happening, how things are changing. And you can even go in and manually force the plan by using unforce the plan as well. So good set of DMVs there that will show you what's happening with these query recommendations. A lot of DMVs have been enhanced. It's not just having these new DMVs for the query store automatic tuning. They've put in a lot of DMVs now where before you might have had to use DBCC, which you can't use in Azure SQL database. So because we don't have DBCC in Azure SQL database, they're trying to take a lot of these things that you may have used DBCC for and actually put them into DMVs now. So you can see things like VLF infos in there. You can even go and look at statistics as well. Look at histograms. You have to use DBCC statistics. You can actually, there's a history, you have to pull out the histogram from the stats as well via a DMDB stats histogram. One of the things to notice is that there's a new DMV, DMOS host info, whereas before it was DMOS Windows info. What happens now is that you need to actually be SQL Server's platform independent. So they're now saying use DMOS host info, which also works on Linux as well, and gives you a bit more information. For example, it'll tell you if you're on Windows, if you're on Linux, it'll tell you whether it's Ubuntu Linux, Red Hat Linux, or SUSE Linux. So it can actually tell you which variation of Linux you're on as well. And so a lot of good DMV information coming out. If you're looking at licensing, there's DMOS sysinfo to give you things like socket count, cores per socket, NUMA node count, without having to actually go on the machine and start to look at the Windows level. You can see how many sockets have I got on this machine. So a lot of this is coming away from using other methods of getting information and put it just directly into the DMVs. You have resumable index operations, which I'll come to, and there's a DMV for tracking that as well. Some of these things do need things turned on. For example, if you're going to look at this particular one, you need letting statistics profiling turned on. So set statistics XML on or set statistics profile on, or you can turn on the extended event query post execution show plan, which is an expensive extended event, but you can do that to get these DMVs this particular DMV working. And there's even a trace flag and another extended event for lightweight statistics profiling, which is perhaps not that well known. Trace flag 7412 or query thread profile, there's an extended event for that as well. So they reckon that the actual overhead on this is about 1.5 to 2% to turn on this lightweight statistics profiling as well. So it's not that much overhead. It's perhaps a better way. If you don't necessarily want to turn on full query store, you can turn on lightweight statistics profiling, and actually, which came in since 2014 SP2 or 2016. So there are other perhaps not quite so well known methods of actually getting information out of the server, and that allows these DMVs to work. There's show plan enhancements. So I can use DBCC now to look at, so I can use DMVs now to look at statistics and get statistics histograms. In the actual plan, you now get the actual, which statistics were used by the optimizer. So you get the sampling percentage, the current modification count, and when it was last updated. So you're actually getting more information in the plans as well. If I switch across to one of my servers, I'll go off and create a database. Use that database. And I show plan demo. So if I create a simple table, just a numbers table with just an integer in it, and then so I'm just going to put 1,000 numbers into the table. It's a little trick to actually just put 1,000 numbers directly into a table. Update stats with full scan. Go in and enable the actual execution plan. with a simple table scan. So I'll use the other one. It's a bit bigger. You should be able to see. There we go. What's your stats? What's down here somewhere? You can actually see the. Oh, there we go. Stats usage. There you go. So you can actually see there's an additional bit here which optimize statistics usage. There is where you can actually see which statistics got used. So you can see the name of. If I drag that over a bit, you can see the name of the statistic. You can see which table it was on. You can see what sampling percentage had been used when the statistic was created, when that statistic was last updated. So all this information is now in the actual and in the estimated execution plan as well. So you can actually see which statistics the optimizer was actually using, and without having to go off and actually go and get the XML of the plan and dig into the XML to find all the detailed information. They've put this straight out on the properties now, so you can see this quite nicely on Management Studio. And also that would be in, I'm expecting that to be in SQL Operations Studio. So as well as Management Studio, there's now a thing called SQL Operations Studio, which actually runs on Linux as well as Windows. And that has plan information in there as well. Just file out. So you can run queries in here as well. And you can actually, if I take that query across. So this is the cross-platform equivalent of Management Studio, where you can actually run queries, and that's not going to paste. Okay. So but you can actually get the plan in there as well, and they've actually got the graphical plan that came in quite recently. I'll leave that for now. But the so yeah, the plan has the which statistics the server is using. We have more intelligence coming into the optimizer. So the first iteration of this is for multi-statement table value functions, T-SQL functions. What they now have is what's called Interleave Execution, which actually changes the query plan as the query is actually running. So whereas before, with multi-statement table valued functions, there was a fixed estimate for the number of rows returned. So which is 100 for SQL Server 2016 or 1 for SQL Server 2014 and earlier. What happens now is if you've got a multi-statement table value function, the optimizer will not do the full optimization of the plan before it starts execution. What it will do is it will do some of the optimization for the plan, and actually go and pause the optimization, fully execute the subtree of the plan, which includes the multi-stable table value function, i.e. materializing that part of the plan and getting the actual rows start to come out. And as rows come out, it will initially go, I'm going to use for a small number of rows, initially use a nested loop join. What happens if the number of rows goes above a certain threshold, and that's dynamically calculated, is it will actually go, okay, this join, this adapt, they call it now an adaptive join, started off as a nested, starts off as a hash join. If the number of rows actually turns out to be quite low, below the threshold, it will switch to a nested loop join. So it starts off building the hash probe table, and if that probe table ends up being quite small or below a particular threshold, it will then flip to a nested loop join. Sorry, I'm confusing two things here. So this is multi-statement table. Sorry. Let me start this again. Table value function here. Sorry, the table value function, it does materialize the full table value function and then actually goes off and carries on optimizing again. So it does the whole table value function and then it will go off and optimize the rest of the plan. So at the moment, it's what they call interleaved execution. Multi-statement table value function must be read-only and not part of a modification operation. And you can't use that if you're on the inside of a cross apply. And it must be compatible with level 140. So the idea is fully execute the multi-stable table value function, get all the rows out. At this point, we know how many rows are coming out of the multi-stable statement table value function. And we can then go back and optimize the rest of the plan with the fact that I'm not using a fixed estimate of 100 for 2016 or 1 for 2014 and below. What actually happens is I know what the estimate is, what the actual values are coming out of the multi-statement table value function, and therefore I can optimize the plan without using a fixed estimate, but using the actual number of rows returned. I do have an, let me run the demo for that one as well. Makes this a bit clearer. So I'm going to create two numbers functions, two numbers tables, one with a clustered index. I'm going to put 1,000 rows into that first table. I'm going to create a multi-statement table value function. What this is going to do is say, I take an integer parameter, and that parameter is then used to actually select for the rows that's coming back. So as my table contains what numbers 1 to 1,000, what I'm saying is if I pass in 800, only give me numbers greater than 800, so I only get 200 rows back. So what I'm doing is I'm saying this parameter comes into the multi-statement table value function, determines how many rows I get back. So as I change the parameter, the number of rows that come back from the function will actually change. So if I pass in 800 for now, that means I just get anything where the number's greater than 800, so I only get between 800 and 1,000. So what happens in my plan is that from here, what you actually see is that the estimated number of rows to be returned is actually 200. So I only return 200, rather than coming back with the 2016 default of 100 or the 2014 or earlier value of 1. It actually executes the table value function, finds this 200 rows, comes back and uses that as the estimated value of 200, and then goes off and re-optimizes the rest of the plan. So it then says, okay, there's only 200. I'll do a nested loop join. So it can actually, the estimate is always correct coming out of the multi-stable table value function. It's the actual number of rows that were returned. So if I change this, say, to 700, which will return me all rows greater than 700, i.e. it'll give me 300 rows. Go back and execute. And this time, the number of estimated rows becomes 300. So every time you find that, for multi-statement table value functions, the estimated number of rows will actually always be the actual number of rows that came out of the multi-statement table value function. So it's optimized this part of the plan, and there could be things below it, but it'll actually optimize this part of the plan, then get the actual number of rows and use that as the estimate, and then go back and optimize the whole rest of the plan based on the fact that it now knows the correct number of rows that have come back from the multi-statement table value function. So making the optimizer dynamic. And there's actually a new feature on top of that, which is again making the actual optimizer dynamic, which is actually called adaptive joins. We have an adaptive join operator. What happens is you're doing a join, you normally might have a hash join or a nested loop or a merge join. In this case, it only ends up either, it has what's called an adaptive join. So it will either be a hash join or a nested loop join. What it will do is it will first go off and scan the first input into the join, work out the number of rows that are coming there. So it does a hash, builds the hash probe table, It says how many rows have I got back, and then if it finds it actually has below a certain threshold, it won't actually end up doing a hash join. It actually switches to a nested loop join, which is more efficient. Well, one restriction on this is that the first table that's being scanned to build the hash probe table must have a column store index and must be using a column store index scan. So at the moment, this only works with column store indexes on the first table that's being scanned in the query, in the join. So it's not clearly documented. What this says, a range of rows and associated costs is defined for both join types, and then that decides where the threshold is. Microsoft don't really document how the threshold is calculated. It's just the fact that below the threshold you go in a loop join, above the threshold you go to a hash join. And the thing is, the adaptive joins actually do look quite different from normal query operators. So if I go back and create a numbers table again, a numbers one table, and I must create a column store index on this numbers on the first table, numbers one. So it has to be a column store index. I'm going to populate that table with just 10 rows. I'm going to populate a second table with 100,000 rows. That might take a little bit of time. As I've populated a table that contains a column store index, after creating it, I need to reorganize that so that the column store index, it takes everything out of the Delta store and puts it into the actual row groups. So I get batch mode execution. I'm going to create another table. So I'm going to join, so I create a numbers two table. I found in my testing I needed a non-clustered index. I actually found in my testing of this, when I was testing this using the CTPs before RTM came out, this was quite a very, very specific way you had to do this. This had to be a clustered column store index on the first table, and it had to be a non-clustered index on the second table. So it was a very, I think that restriction might have been relaxed when it went to RTM, but initially it was, sorry, that's already there. When it was initially done, it was quite a prescriptive way of doing it. We had to actually have it exactly. So if I take my second index, I'm going to reorg that as well. So everything's reorganized, everything's nice and optimal. Go off and look at my plan. Full plan. So what I'm actually going to see is an adaptive join. So normally a join, you'd actually expect two operators to come into it. In this adaptive join, you actually see there's three lines coming into the adaptive join. Which looks a bit odd because I'm joining two tables. Here I've got 3 lines coming in. And the way this works is that the initial scan, the initial column store index scan appears as the top operator. There. Then two more appear. One is the actual hash operation, which would be used if I was going to do a hash join. And the other one is the actual nested loop join via an index seek onto a non-clustered index. What we can see is that it's not very, perhaps not that clear, but what you actually see is this line is actually slightly thicker than the other one, I believe. So yeah, So what happens is the actual join type becomes a nested loop join, and the estimated join type is nested loop as well. So what's happened is the adaptive join, so its physical operation is adaptive join, the actual join type is nested loop, and the estimated join type is nested loop. So what happens is it's done the initial scan, it's had these two possible ways of doing the join, and it said I'm below the threshold, so I go down to the bottom one here, and I actually use a nested loop join, which means that becomes slightly thicker, which you can see actually means that we actually switched to doing a nested loop join because there were so few rows. So just be aware there's an adaptive loop join, and this is how it works. So you've got the initial scan, and then the two options, and you can see which one of the options was actually chosen. Be aware you need to do Management Studio 17 to be able to see the adaptive join operator. So I believe 7.5 is the latest. So, but you need to be on the latest Management or 17 Management Studio to be able to see these adaptive joins. Again, you need compatibility level 140, and it's actually a batch mode operator. So the hash join has to be a batch mode join. That's why you need the console index to push into the batch mode. What happens is because we're doing an initial probe of the first table, so initial scan of the first table and building a probe table, what that means is I need memory to build that probe table. So although you may end up doing a nested loop join, you actually need the memory as if it was a hash join to build that probe table. So you might find that although the adaptive join ends up being a nested loop, the memory requirement is quite similar to it, or partially similar to it being a hash join. And there is, if for some reason it can't do an adaptive join, there's actually an extended event called adaptive join skipped, which will tell you why it could not do an adaptive join as well. So they're always growing the number of the list of extended events. A nice one is, in order to keep things up and running at all times, is online index rebuilds are now resumable. So if you're doing an online index rebuild and you had some kind of failure, let's say you ran out of disk space or your availability group failed over, what happens now is online index rebuilds can be paused and resumed, and it does not hold open a transaction, so it does not require significant log space. What happens is you can actually say, go in and say, pause my online index rebuild. So I won't run the whole thing, but basically the way it happens is, and I will make this available, is you say, go off and do my alter index rebuild. There's another option saying resumable equals on, which you must specify to make this a resumable online index rebuild. And you can then go in and you can then go in and here's what my other session will be, is you can actually go in and say, take my alter index. You don't even need to know which session's doing it, which user's doing it. You just say alter index, or whichever the index on the table, pause. And it will actually pause that index rebuild. It doesn't hold any active log space. It's keeping track of where the second copy of the table is, but it's not holding an open transaction. Got the full demo here where we actually go and look at the statistics for the log via one of the new, I believe it's one of the new DMVs, where you can see information like log since last checkpoint and log recovery size, and you'll be able to see that this is not actually holding on to the log. It's keeping track of where the second copy of the table is for the rebuild, and it keeps enough information, and it doesn't actually say where they keep it, but it keeps enough information that you can then go back in and say alter my index and do a resume on it, and it will go off and resume that index rebuild and actually catch everything up, fully transactionally consistent, and it will go in and actually finish the index rebuild. So if, for example, you've got a system, it's obviously it's online index rebuild, so you're trying to keep everything up and running, the index rebuild's taking up a lot of CPU or a lot of disk I/O, taking a lot of resource. You can pause that, let your batch of processing run through. When your batch of processing is run through, say end of day reporting or something, or end of day trade settlement, you can then go back and resume your online index rebuild. So for very large environments where online index rebuilds can take a long time, you don't want them hogging resource on the server. You want to be able to pause it, run some processing, intensive processing, and then go and resume it. You can do that now. Again, it's making everything much more online and available. So quite a nice one. They've had in-memory OLTP, again, always improving things. OLTP performance has been improved. So now, if you're doing a database recovery, if you're doing an unclustered index rebuild for a memory optimized table, it's much more significantly optimized. There's not too much detail on this, but basically the database recovery basically doesn't become massively slow when you're doing memory optimized tables with non-clustered indexes. And what happens is the transaction log redo for memory optimized tables is now done in parallel. Amazed, they're always improving these features. They've even made alter table faster as well against memory optimized tables in most cases. And you can actually put your memory optimized file group on Azure storage as well now. It's not exactly stretching your database, but it's being able to put file groups now on Azure storage as well. Always helping you to get across to the cloud as well. So yeah, OLTP, memory LTP is getting better. In terms of in-memory, they're actually, the thing that initially restricted it back in 2014 was the actual T-SQL surface area was quite small. Things like you didn't have outer joins. What's happened now is they've taken away even more of they took away some of the limits in 2016, but even more of the limits in terms of the T-SQL surface area for in-memory have actually gone away. You can do SP space used, you can do SP renames, you can rename memory optimized tables and natively compiled T-SQL stored procs as well. The limit of 8 indexes on a memory optimized table has gone away as well. They're allowing computed top and case is now supported for T-SQL modules. Computed columns are supported on memory optimized tables, and you can index computed columns on memory optimized tables as well. And you can even start to bolt in JSON as well and use JSON in natively compiled modules and even in check constraints as well. So 2016 added JSON, 2017 they've combined JSON within memory now as well to some extent, and I'm sure they'll keep on improving this. Is JSON can now be used in natively compiled modules and check constraints. You see all these features come in, and gradually each of the engines, so there's a column store engine, there's the old row store engine, there's the in-memory engine. The row store engine has a vast amount of features. Gradually what's happening is the in-memory engine is actually picking up these features that had the row store engine had, and the column store is also picking up features that the row store had. The two new engines are always being improved, picking up features. Availability groups. I said I wouldn't mention Linux here. I'll just briefly cover it in here. You can now have clusterless availability groups, so you don't actually need a cluster. So you can say, I want to do an availability group from Windows to Linux, and primarily this is for migration to Linux. They've made it very, very clear, and it was at SQL Bits as well. Travis Wright was making it very clear. This is not an HA solution. It's cross-platform. As it's cross-platform, there is no cross-platform clustering software. There is no cross-platform clustering software. So what happens is it's not an HA solution. You don't have a cluster. You don't have automatic failover. If something goes wrong, you have to spot this yourself and do the failover yourself, but you can use it for migrating to Linux. In terms of improving synchronous, when you're using synchronous secondaries, what's happened now is you can actually say that I want a minimum number of secondaries to be able to commit. And then if that happens, the primary will then be able to continue. So what happens is the primary goes and starts a transaction, and you can say, I want at least some of these synchronous secondaries to commit before the primary commits the transaction. So the primary will actually, rather than carry on, the primary will actually wait and won't commit it and put the availability group, it won't go into a bad state. What happens is if there aren't enough if you're lucky enough to have multiple secondaries, you can say so you've got 2 secondaries replicas. You can say at least one of these must have committed, and as long as one of these is committed, then the primary can carry on. I'm quite happy that the fact that I've got it. Okay, I've got 2 secondary synchronous replicas, but as long as any one of those 2 synchronous secondary replicas is committed, then I'm quite happy for the primary to carry on. So this is obviously for large sites that have more than 1 synchronous replica, but they've got that now. It doesn't have to wait for everything. You can say as long as one of them has committed, then managed to commit, then the primary can commit and carry on. So yeah, that covers it. Most of that there. I've put the detail in there. If the minimum number of replicas required for commit is not available, then commits on the primary fail. At which point your primary can start to, obviously it can't commit, so it can't free the log. So the log can start to grow and fill, and then you can start to have problems. You can do this when this required synchronous secondaries to commit. It's supported for alter as well, so you can always change your mind further down the line. CLR keeps on improving. They've had a few attempts at how to work out how to do this. What happens now is they don't completely trust the code access security in .NET framework for CLRs. It's not supported as a security boundary anymore. So what they found was if you create a CLR assembly created with permission set safe, which in theory should not be allowed to call access external system resources or call the managed code, then what actually happened was they found that actually, even though permission set was safe, there were ways around this to actually be able to go to access external resources. So what happens now is there's a CLR strict security option, which means that safe and external access assemblies are treated as unsafe. So what they're saying is, we don't even though you might put a permission set of safe on your CLR assembly or external access, we no longer completely trust that. So we still treat it as if it was unsafe if this CLR security is on and the default is to have it enabled. What they recommend now is that you sign all your assemblies via a certificate or an asymmetric key and have an associated login that has granted unsafe assembly permission in the master database. I've actually got the full demo here for that, which is, I'll just briefly talk through that. So what they said is if you want to actually have your assembly trusted, what you have to do is you turn on CLR strict assembly. By default will be turned on. You go and create your assembly with a permission set of safe. What you have to do then is go into Visual Studio. I've got this is for 2015. I've got the path here. Add your user defined function with some sample code there. Then go into the properties for the project. Go into SQL CLR and you can sign your assembly. So you tick the assembly and you sign it and you create a key file associated with that, which contains your private public key pair to use to sign your assembly. You go off and build your solution, and that'll go into a debug folder there. You then go and create an asymmetric key from your signed assembly. Create a login from that asymmetric key. Grant that login unsafe assembly. And then you can go in and create your assembly with permission set safe, and the assembly, because it's associated with it's signed and it's associated with and then you've used that signed assembly to build an asymmetric key, attach that to a login, and granted unsafe assembly to the login, it now means your assembly will actually execute. It's trusted now. So it will work. So it's a bit of a long, complicated process, but it does mean that they're now being they're being stricter in terms of security around CLRs. Just for those who use CLRs. Graph database. So we have the row store engine, we have the in-memory engine, we have the column store engine. They've now added a graph engine as well for doing graph queries. So the way graph works is that you have nodes, which is say a person, and another node, which is say a topic, and you can define a relationship between two nodes that says this person likes this topic. And then you can start doing some quite interesting queries with that. So I'll give you a demo of that. One sec. One sec. Let me just find that demo. It's not there. For some reason it's not coming up off the solution. Let me take that demo out. Just drop that on the desktop. Okay. So what you do is you say, okay, I want to create two nodes. One node is a person, one node is a topic, and I want to create an edge between these two that says this person likes this topic. So there's slightly different syntax for this. You create your table as normal, but then on the end of that, you say create it as a node. And then you go and create your topic as a node as well. So you create another table with as a node. And you then say, might seem a bit odd, but you're saying, okay, I'm going to use an edge to tie these two nodes together, tie the person to the topic. And all you actually say for edges is create a table, just the table name as edge. Which does seem a bit strange syntax because I've got no columns, but we'll see how this works. It actually has two kind of hidden columns that you automatically get for edges. And because you've created tables as nodes, we go in and create a person, and we create a topic. I'm going to put another one. Some of the community might know Nico. He's the expert on column store. So I'll put he likes column store, and I like graphs. And then the weird thing is when you want to actually link this person to this topic, it's a slightly different syntax. You say insert into my edge table a to and a from, and you have to actually go and select this node ID from each table. So actually one becomes the node ID from the to, one becomes the node ID from the from. So it's a slightly different syntax where you can actually associate a person with a topic. So you can tie two nodes together via an edge table. So it's a bit of a weird syntax. And what I wanted to wonder how they implemented this. So I actually dug into how they implemented it. Yeah, okay. So the way it works was we actually it actually uses JSON in the middle. So you actually find that this node ID, there's a hidden node ID column, which you can reference up here as node ID, but it actually ends up with a GUID on the end, and it's actually using JSON on the end. So each table basically gets a hidden column, which is this node ID, with JSON, which actually contains the text of another copy of the rows in the table. And then the join, oddly enough, the join table is actually an edge saying this is what the table is, and it actually contains a from and a to, which is how it actually stores them internally. So they're actually using JSON inside tables to actually do this graph database. And then what you say is, I want a find me a person where there's a relationship between the topic and the person via the edge that you created. So it's slightly weird thing. If you join all three tables together and then use this match to say this topic as an edge, a likes edge from this person. So say person likes topic. And you actually get the actual join. You don't have to stop at one relationship. You can actually say, dig this further down, put another arrow and use another relationship. So you can say, find me people that like this topic that's then liked by another person. So you can start to do these graph relationships and actually see, drill down at least a few levels. There are actually improvements coming in next release about this. It's quite a simple query at the moment, but people who know graph databases know you can do more than just say follow edges. But this is what's in 2017 at the moment. You can put Python in there as well. You had R in 2016. We now have Python in 2017. And the simple thing is, if you're doing a bulk insert, you can now load directly from CSV files as well. I'll keep it a bit short here, just keep it quite simple. There are some bonus items. Things like if you're doing a backup for a small table, but your SQL Server, say, has a terabyte of memory, so massive memory, it doesn't keep scanning the buffer pool multiple times while it's doing the backup of a small database. So if you've got a large memory and you've got a small database that you're backing up, the backup becomes much quicker with 2017 because they're not continually scanning the whole buffer pool every time when you're doing the backup. Query Store now includes weight stats as well, various little enhancements. System version temporary tables now support cascading deletes and updates. The column store now supports lob columns as well. You have retention policies for temporal tables. There's a few database tuning options. There's a few new string functions, so we finally got trim at last, which I think quite a few people have been asking for. It's finally appeared. And there's some string aggregation ones as well. You have various performance improvements and collation improvements for Japanese databases. SQL Server 2017 CU3, they came out with packet weight, and they actually enhanced packet weight. And it says, if I've got a packet weight, there's two. You have a parallel query. You can either have producers are sending rows to consumers. What they've done, they split that to make it a bit more understandable. If the consumer's waiting, so in other words, the producer's not producing rows fast enough, what happens is it says that's not so important anymore. If the producer's producing rows too quickly and the consumer can't consume them quickly enough, that becomes actionable. So they've actually split CX packet weight into a new CX packet weight and a CX consumer weight. So if the consumer's waiting, don't really worry about that. It's more if the producer's waiting and the consumer can't consume quickly enough, then you might want to throttle the consumer back by reducing the parallelism, max degree of parallelism, or increasing cost threshold for parallelism or cardinality estimates. So that's come out. And CU4, they've added Java 9 support for Polybase as well, and you can slipstream that straight in, which is what I did for building my SQL Server here, where you can actually slipstream that and use Java. If you just install Java 9, which is what I did, you actually can use Polybase with Java 9 as well. So it's always, as new Java versions come out, they're even putting these into CUs now. Service packs have effectively gone away. It's now monthly CUs. And as they're done, as the CUs go out to, everything in the CUs goes out to Azure first, pretty much everything. It means that it gets a lot of testing in Azure, so they're confident that the monthly CUs are reliable. There are no service packs anymore. They say keep current with the CUs. If you want support, what might happen is Microsoft may turn around and say, first put the latest CU on. If you still have the problem, then we'll look into it further. So they may want you to do that first, and they may well suggest that as the first option. So they want you to keep fairly current on the CUs. As they pre-tested in Azure, they should be quite reliable. And 2018, this came out from SQL. This slide is actually directly from SQL Bits. They're coming out with local logins. They're doing merge and transactional replication on Linux, local logins on Linux, i.e. they support Windows authentication. They're going to support Linux authentication. They're going to support more integration with big data and SQL Graph enhancements, as I said earlier. So that's being worked on at the moment. So the merge and transactional replication for Linux, they said it was being worked on. Local Linux authentication was being worked on, and Bash scripting and SQL agent jobs has been worked on as well. So these are some of the other things that came out from past Summit 2017 as potentially has been worked on, and there actually are private previews. Batch mode for a row store, so you don't always need column anymore. You can actually have a row store and get batch mode and get that performance improvement. Memory grant feedback came along, and that's actually works for row. Also, basically batch mode, that's now coming as row mode only. You had multi-segment table valued functions getting deferred compilation. That's coming, and optimizing. That's coming along. Scalar UDF inlining is coming along, and something that comes very similar to Oracle. They're even doing approximate query processing, approximate count distinct, which Oracle does already. That's coming along, and you can contact Joe Sack on Twitter to join the private preview for that. Lots of nice features coming along. They've enhanced always encrypted. What they're doing now is they're using a thing called enclaves, so you don't have to have so much bandwidth across the network because it's client-side encryption. You have to send everything across to the client to encrypt it, and actually that required bandwidth to the client and CPU on the client. Now they have this thing called enclaves come along in latest Intel CPUs SGX, where you can actually use the thing called enclaves. So that's being enhanced as well. And I've got all the references on here as well. I'll put the slides up. I can send the slides to the moderator. Well, that's what's coming up.
Thank you, Dave, for an interesting presentation. And I would appreciate it if you'd send me the PowerPoint and also your demo scripts.
Yes, I will do.
Just a couple of questions. Is SQL 2016 to 2017 more of a migration or a full upgrade? I thought I upgraded to 2017 from 2016, but my version is still showing 13.0 instead of a 14.0 type number.
It would be a same as all the other upgrades from same as 2014 to 2016. It's another upgrade. So it should do one thing to be aware of is check your database compatibility version as well, because that needs to be changed as well potentially. But it's just another upgrade as another SQL version. There's nothing special about it.
Another question, the query store reports in Azure SQL is very limited. Is there a way to move some of the on-premise query store reports to Azure SQL? Is there a way for a user to create their own query store reports for Azure SQL?
I would imagine so. You should be able to. The query store data is available as a database, so you should be. It's within the database, so you should be able to go and query it. So I think I'm about to get kicked out now, actually. So I think I better wrap up and go. Sorry.
Okay, I've just got one more question. What is currently we are running the SQL 2014. What is the next stable version recommendation to consider for an upgrade?
2017 CU4 is considered stable. It's all pre-tested in Azure, so the official advice from Microsoft is that it's considered stable. Don't forget that when you upgrade, you don't have to do the full don't have to change completely. Keep the database compatibility level as the old version. And as I said at SQL Bits, if your query plan changes shape in any way, as long as your compatibility level has not been updated, then in 2017, if your query plan changes and you're still on the old compatibility level, support have been told that is a bug and must be treated as a bug. So in terms of query plan regressions, if you stay on the old compatibility level, you should not get any plan changes. Obviously, if you're doing the migration, if you move to different hardware, then that may cause plan slowdowns. But in terms of plan, the actual shape of the plan and the plan that you get, it shouldn't change as long as the compatibility level has not changed. And I got that in writing. I'll put that on Twitter. Actually, that's actually writing from that was actually directly from Microsoft, and they put that up on Twitter as well.
Okay, thank you very much, Dave. I think people have learned a lot of exciting things, and I'm going to end the meeting, and just remember to send me the PowerPoint and your demo script. Yep. Thanks a lot. Bye-bye.
Thank you. Bye.